So our final topic for the day is the variational principle. It's a very important principle, and it's in some sense deceptively easy to prove, but you have to have the right proof in front of you. So what we're trying to prove is that if I take any wave function psi, right? So for an arbitrary wave function psi, if I compute the expectation of the Hamiltonian, what I want to prove is that this must always be at least equal to the ground state. So again, this is the question mark, what I'm trying to prove. And there's a secondary proof, and it's equal only if psi of x actually is the ground state, or as we've been saying, related by some constant, which I will call W naught, say, times the ground state. Something like this, right? It's equal only if psi is the ground state. Now, to prove something like this, the first thing we notice is that, well, I've got to get the energies involved somehow. This is sort of my inspiration, right? So to get the energies involved somehow, I have to think how this expression relates to the energy of the different states. But you will recall, this is nothing other than the average energy. And the average energy can always be computed, right, in the energy representation, where it is a sum of those weights in the quantum principle of superposition times the corresponding energy values. And another way, by the way, to look at this that it helps reduce the writing is to recognize, of course, that the square of those weights are nothing other than the probabilities. So I really just have the definition, really, of the average. Next, I want to relate this in an inequality to E naught. Now, from a practical point of view, to prove an inequality, basically the only way to do that is to subtract both sides of the inequality, and then to prove that the result is positive. So to get that subtraction going, right, one thing that I can do is to subtract E naught from both sides of my equation.